Are you still? Yes, I'm sure. Here we go. We're live.
We're live. Hi everyone, back to another of our user group meetings. Today we've got Velida, who works for ASB Bank. He's a software engineer there, and he's a recent Microsoft Data Platform MVP, doing a lot of stuff in .NET and Azure, and he speaks to a lot of conferences virtually at the moment. He spoke at SQL Saturday in Brisbane, at the virtual MA-Net conference in Washington, and at the recent Connected Systems Bootcamp in Auckland. You can ask the questions in the Q&A panel, and we'll address them at the end and go through them. There will be some time at the end for questions. Also, we've got some swag, so just listen to what Will's got to say, and at the end we'll ask some questions, and there'll be some swag based on your answers. And without further ado, over to Will.
Cool, thanks Rory. Good afternoon everyone. Thanks for joining me for this Auckland Azure meetup. Like Rory said, my name is Will. I'm a software engineer working for ASB Bank and a Microsoft Data Platform MVP. Now, wherever you're watching right now, I know New Zealand's just moved into level 1, but whether you're watching in Auckland, anywhere else around the country, or maybe even anywhere else overseas right now, I hope that you're staying safe and healthy during these challenging times. I'm really excited today to be talking to you about developing hybrid transactional and analytical processing solutions with Azure Cosmos DB and Azure Synapse Analytics. This is a feature that came out into preview at Build 2020, and I think it's a real game changer when it comes to performing analytics using Azure Cosmos DB. Now, whenever I do a session about Cosmos DB, I'm always interested to see in the audience who's heard of Cosmos DB, who's using it, whether they're using it in production or they're just playing around with it, just to get some kind of expectations about who I'm talking to and where I can tailor the conversation where I can. But since I can't physically see you, I'm just going to set the expectations right now by saying you don't need to have had any experience using Cosmos DB or even Azure Synapse Analytics for that matter to be able to follow along. Whether you've just heard about it, whether you're an expert in it, whether you're using it in production right now, this session is just designed to show you how you can build really high-performing analytical solutions using Azure Synapse Link for Cosmos DB. So just to introduce myself a little bit, like I said, I'm a software engineer for ASB Bank in Auckland, New Zealand. My main focus is Azure Cosmos DB, but I also work with Azure Functions, starting to get into Azure Synapse a little bit as they're starting to open up the preview a little bit more, Azure Databricks and .NET in general. If you haven't picked up on the accent, I'm originally from the UK, but I've been living in Auckland, well, Auckland for 8 years now, and prior to that, Christchurch for 2 years. So I've been in New Zealand for about a decade. I'm slowly warming up to the idea of wearing an all-black shirt instead of an English rugby shirt. So in today's session, what I'll go through is we'll do a high-level overview, of what Azure Synapse Analytics is and what Azure Cosmos DB is. And then I'll talk a little bit about what it was like to actually perform analytics on Cosmos DB before Azure Synapse Link came along, and a little bit of the pain points that it caused for developers and analysts alike. Then we'll get into the meat of our presentation and really talk about what Azure Synapse Link for Cosmos DB is, how it works, what the Azure Cosmos DB Analytical Store is, which is a big part of it, what benefits Synapse Links provides us when we're developing analytical solutions using Cosmos DB, and in what situations we'd actually apply or actually use, Synapse Link. Then I'll go through a little bit of a demo of how all the parts work together. My demo was slightly working before the presentation. I did a last-minute sound check, and it seemed to be working. So hopefully the demo overlords are smiling on me today. And we'll get through it really, really well. As we go along, feel free to think of any questions, like Rory said, and then at the end of the presentation, I'll answer them. And then I'll also answer a question to you guys, so you can win some swag. So with that out of the way, let's start by introducing Azure Synapse Analytics and Cosmos DB. Now, performing analytics in the enterprise today requires operating on not just a massive amount of data in one storage, but a different, also a variety of different data types. In the past, we would have had to pull technologies like Spark and SQL together and integrate them into pipelines in order to gain any reasonable or interesting insights into our data, whether that would be if our data was sitting in relational data stores or data lakes, whatever. And these systems are pretty complex and they take time to build properly in order to build systems that can actually give us intelligent insights that we're trying to look for within our data. And what Azure Synapse is, it's an integrated analytics service that can help accelerate this process, and it scales across data warehouses and big data systems. We can use SQL and Spark within the same place and environment and use pipelines to orchestrate our data movement in a really nice integrated unified system. Synapse comes with a web native studio user experience that provides the single experience to managing and monitoring and securing and coding our data projects. Essentially a unified experience that brings everything that data engineers need in one location. It also integrates really well with Power BI and also has built-in support for Azure Machine Learning. So Synapse is really, really effective tool for allowing developers and data engineers to build a really complete solution. And just for those who aren't familiar with Azure Cosmos DB, Azure Cosmos DB is Microsoft's globally distributed NoSQL multi-model database service. So Cosmos DB allows us to elastically and independently scale both through throughput and storage to any Azure region worldwide. Cosmos DB is classed as a foundational service, so you can provision a Cosmos DB account in any Azure region in the world. You can build databases that use documents model type data using the SQL API or MongoDB, columnar data using the Cassandra API. If you need scalable key value data storage, you can use the Table API, which is essentially Azure table storage at a distributed level, or you can build graph databases using the Gremlin API. Cosmos DB provides you the ability to build highly responsive and available applications worldwide. So essentially, this ensures that wherever your users are in the world, you can bring your data as close to them as possible. You have guaranteed low latency for both index reads and writes at the 99th percentile all around the world, which really helps provide extremely quick and fast query times. There's also multiple consistency options to choose from. So traditionally with distributed databases, you'll have a trade-off between two extremes, so whether that's eventual consistency or strong consistency. Cosmos DB provides us with 5 well-defined consistency levels for us to choose from, depending on our use case. Also, another benefit for Cosmos DB, there's no schema or index management. There's a little bit of caveats when it comes to index management, but essentially it's when we persist documents or persist data into Cosmos DB, index is handled for us. And one question that came up at SQL Saturday Brisbane is, well, where would you actually use Cosmos DB? And there's a variety of different scenarios that we can actually implement Cosmos DB depending on our applications. The Cosmos DB team have made real strides to really lower the bar of entry in terms of functionality. So if you have web applications that need lightning quick NoSQL databases, you can use it for web apps. It's quite prevalent in IoT applications. If you've developed a mobile game and you're serving users all around the world, you can actually use Cosmos DB to ensure that they're interacting with a copy of your data as close to them as possible. At ASB, we use it quite extensively as an event store using as part of our serverless architecture. So really, it's a great service that brings huge amounts of developers who just want to work with a database really quickly, and that can scale quickly and easily as well. However, when it comes to performing traditional analytics on Cosmos DB, there are a few limitations, and there's some complications that we would encounter day to day. So at this stage, it's really important to discuss what throughput is in Cosmos DB and how that affects our ability to perform what you could class as traditional analytics on our data. So throughput is in Cosmos DB is expressed through a concept called request units, and essentially request units are the currency that we use in Cosmos DB to perform operations. This is referred to as RUs for short. As if you go through documentation, you see RUs, that essentially just means request units. And this is an abstraction of system resources required to perform operations against our Cosmos DB account. Now, this isn't limited to a particular API, so this is a concept that applies to all APIs and all different data models. And any action that you perform against your items in your Cosmos DB account will cost request units. You're charged for provisioning request units at an hourly basis. You can provision throughput at a database level or at a container level. And during the demo, I'll explain a little bit. I'll just show you very quickly how this is possible. We can either set this manually, so we can set like an upper limit, a hard upper limit for our containers and databases, or the Cosmos DB team have released autoscale, which essentially you set a maximum value that you want your containers to scale up to, and it will sit idle at a low level. So for example, if I set a maximum value of 4,000 request units, it will sit at 400 request units, and it will scale between 400 and 4,000 request units depending on the traffic and incoming request against your database. So with Autopilot, you set it at a maximum level and it always sits at 10% of your provision value until you start making requests, and then it just scales automatically up and down to make sure that your requests aren't throttled. Also coming out soon is a serverless option. So this is coming into preview soon. So when we provision throughput in Cosmos DB now, essentially what we do is we provision throughput to either our containers or databases, and it, regardless of whether we're making operations against our account or not, we will still be consuming request units. So it's just there to providing a steady amount of throughput regardless of what's happening against our databases. And essentially what the serverless option will do is it will only charge you for request units that are consumed when operations are actually made. And that's going to be a pretty cool feature depending on, so yeah, cool. Now, because the way the throughput works, or traditionally works in Cosmos DB, this would put developers in quite a difficult spot when it comes to performing analytics. Now, in order to perform bulk analytics on our data, particularly at ASB when we were trying to perform different types of queries beyond the scope of what Cosmos DB could provide, we would find that we would have to provision extra request units just to cover this. This is a bit of a waste of both money and resources. So essentially, how can I? I'll talk. Okay, sorry, kind of lost my place. Okay, so in Cosmos DB, like I said, indexing is automatically managed for us. Now, depending on the size of the documents that you're persisting, depending on the consistency level that you've set your Cosmos DB account to be configured at, sorry, this also has an effect on request unit consumption. We can customize our indexing policies. So essentially we can implement a couple of indexing strategies where we either choose which paths within our documents we want to index, or we just so by either including the paths we want to index or excluding the paths that we don't want to index. And then depending on query types, we can create something called composite indexes. So if we're performing queries where we have to order by ascending or descending, we would essentially create those composite indexes together to try and improve the efficiency of those queries. However, the more and more different types of queries you want to run, and depending on your document structure, you would have to create all these different indexing policies, and it just became a little bit unmanageable. Also, the way that Cosmos DB works with petitioning. So if you're coming from a traditional SQL background, there's no idea of a primary key, but there is a concept called a petition key. Now, petitioning in Cosmos DB, the closest to it is essentially you're sharding your data. So when you're provisioning a container, you'll create something called a petition key. And this is a logical petition. And essentially, as we persist our items, we'll pick a path, a property path within our documents that we want to petition our data on. So say if I've got a hotel container and I want to petition by city name, for example, for every for every hotel that I'm persisting against my collection that's in Paris, those will sit under a logical petition for Paris, and then I'll have hotels for, say, London, Auckland, Brisbane, whatever, and they'll all be logical petitions. Now, these logical petitions are mapped internally to physical petitions. Now, going back to provisioning extra request units to perform queries, what we'd find when we're trying to speed up our queries or perform complex analytical queries, we would scale our containers on our databases right up to 1 million request units. And essentially, you might think, well, the more request units there are provisioned, the quicker our queries are going to run, so that will solve it. However, with these physical petitions, they're essentially SSD-backed machines. So these physical petitions are limited to the amount of throughput that you can actually provision on it, which is, I believe, 10,000 request units at the top of my head. It's either 10,000 or 20,000. I want to say 10,000. And then there's a storage limit as well. So essentially, if you, on the front end, provision, say, 100,000 request units, you're actually provisioning more behind the scenes, more physical petitions, which doesn't improve the performance of your query. So these logical petitions are getting mapped to physical petitions, and then it will slow down the performance of your query. Now, it's good to also mention this idea of cross-petition queries. So using our hotel example, if we wanted to perform a query, we're saying, okay, select all the hotels, their city name is equal to Rome, for example, just to use that as a simple example. We're limiting our query to that specific logical petition. However, in an analytical scenario, we may want to find out where our hotels are. We may want to retrieve data or query on our data regardless of city name. Now, in Cosmos DB, if we want to do that, that's what's called a cross-petition query. And these can be pretty inefficient to run depending on your use case, because if you've got logical petitions sitting on different physical petitions and you're performing cross-petition queries, essentially what happens is it will wait for each query, the result of each query on each logical petition to wait before returning the result to you. And if these are sitting on physical machines or physical petitions, sorry, this can really slow down the performance of your queries. And the reason, the way that data is stored in Cosmos DB containers, they're stored in an indexed row-based transactional store. And this row store format is designed to allow fast read and writes. But as our data set grows, performing complex analytical queries can be really expensive. So in order to do this, in order to move around this, we would usually have to extract our operational data and put it in a separate data layer, such as a SQL database, or maybe even persist it to a data lake. And we could do this in a couple of ways. We could either, for those of you who are familiar with Cosmos DB, there's a feature called the change feed, which essentially what that is, it's enabled by default, and it listens to creates or updates within your container, and you can use that to perform actions. So essentially what you could do is you could have an Azure function with a Cosmos DB trigger, which is essentially initializing the change feed, listen to any creates or updates in your container, get the contents of your document, and then persist that somewhere else. Or we could use Azure Data Factory. But this is adding more components into our analytical pipeline, and this actually increases in complexity depending on our use case. So this is where Azure Synapse Link integration with Cosmos DB and Azure Synapse Analytics makes life a little bit simpler. So this really solves our analytical requirements. It's a hybrid transactional and analytical processing capability that allows us to run near real-time analytics, on our operational data in Cosmos DB. So essentially now, Azure Cosmos DB has something called an analytical store, which is column-based, and it enables us to perform analytics which doesn't require any ETL on our operational data. We can use Azure Synapse Spark or or SQL to run business intelligence, machine learning, or analytical workloads, and this is done without impacting the performance on our transactional workloads in Cosmos DB. Yeah, so just to go through what the analytical store in Cosmos DB is, this was announced at Build 2020 as well, and this is still in preview. But this analytical store addresses the complexity and latency challenges that I described a little bit earlier with creating ETL pipelines or and our row store format. So the column store can automatically sync your operational data into a separate column store, which is more suited to analytical queries. This doesn't require any ETL on our part. There's no change feed required as well, and this is an asynchronous operation. Now, when you're creating your Cosmos DB containers, you can enable the analytical store, and essentially what happens is a new column store is created created internally based on your operational data within your container. This is persisted separately from our transactional store for that container. There's no impact on our workloads when we perform complex analytical queries, and we also don't need to allocate extra request units to do this work. So the cost really is kind of offloaded to Azure Synapse Analytics. Data from our transactional store is automatically synced into our analytical store within 5 minutes. So it's fairly real time, or near as real time as it could be. Now, you might be wondering, well, Will, you've just said that Cosmos DB is a NoSQL database service, and you don't need to worry about schema management. So how can we actually manage this using Azure Synapse? So the analytical store is optimized for analytical query performance. With the auto sync capability, what Cosmos DB will do, it manages the schema inference, which also includes your nested properties. And there are a few caveats to this. But when our schema changes in Cosmos DB, the analytical store will present a unionized schema across all historical schemas within our transactional store. Now, one of the caveats of this, if you've got a Cosmos DB document, and you're using nested properties, say if I have a property called A, as a real bad example, and that A is equal to a string on one document, but then if I persist another document and that A value is equal to an integer, that's where the schema inference gets a little bit difficult. And if you have those kind of situations pop up, you can reach out to the Cosmos DB team and explain your use case for why that might be the case within your documents. But essentially what I believe it does, it just essentially leaves that out of your schema. So you can't, it doesn't come into your optimized analytical schema. Now, if you're familiar to Cosmos DB, you may have heard of the time to live configuration setting that we can set on items or containers for our transactional data store. So what the Cosmos DB team have released is a concept of analytical time to live. This option is only available at the container level, but essentially what we can do is we can indicate how long we want to retain our data in the analytical store at our container level. So this is really handy. So if we're performing a lot of transactions, but we don't really want to store it within our transactional store for that long, but we want to retain it a little bit longer in our analytical store, we can set our analytical time to live, which is configured in seconds, to be longer than our transactional time to live. And inserts and updates and deletes to our operational data are synced to the analytical store irrespective of our transactional time to live. Yeah, and during the demo, I'll show you how you can actually set that up and enable that for your Cosmos DB containers. But the important thing is this at the moment is only available at the container level, whereas in our transactional data store, you can do it at both the container level. So essentially what that is you're setting the time to live for all items within that container, or you can set it at an item level, sorry, which will tell Cosmos DB, okay, I want this item to expire or be deleted after a certain amount of time in seconds. Let me just get some water. Cool. So the benefits of Azure Synapse Link, essentially it allows you to directly access your Cosmos DB Analytical Store without having to create any complex ETL jobs. So in the past, we would have to use something like the change feed, or maybe even the Spark connector for Databricks, if you're using Azure Databricks to connect to Cosmos DB, and then try and manipulate our data that way to get some insights on it. So what Synapse Link does is we don't need to do that anymore. It reduces that complexity, and we don't need to develop our own ETL jobs to do that. Any updates on your transactional data will be visible to the analytical store within that 5-minute period, like I said earlier. ETL systems, they'll usually take you a while to get the results that you want due to the complex nature of it. But with Azure Synapse Link, we can actually just directly query our data, which can really open up some interesting analytical scenarios for us. There's no impact on your operational workloads either. So in the past, like I said, you would have to provision additional throughput on your Cosmos DB account to perform analytical jobs on your data, or implement the change feed to try and store that data anywhere else. And it just felt really, really clunky, and really it wasn't a natural process. And with Synapse Link, you can actually run analytical queries directly against your analytical store. With you can just leave your transactional workloads to just do their thing. And this is far more cost effective, and it allows us to perform analytics at a global scale on our Cosmos DB accounts. So when would we actually use Synapse Link? So if you're using Cosmos DB, you want to run analytics, business intelligence, or machine learning jobs over your operational data. This is a really fantastic way of using it. The use case for Synapse Link Synapse itself provides a more integrated analytics service without impacting your transactional store's provision throughput, like I said. Yeah. Cool. Okay, so let's kick off into our demo. So essentially what I'm going to do, can you all see my portal? Okay, cool. So let's actually go through creating the analytical store.
Hold on. Hang on.
Can you see my screen?
No, we're not seeing your screen. Do you want to share your screen again, and we'll make sure that comes through.
How about now?
Something's happening. There we go. Yep.
Awesome.
Back to it.
Thanks, team. Sorry, that would have been fun if I just kicked it into a demo and all you could see was my face. No, just kidding. Okay, so what I've done here, if I just go to my Data Explorer, essentially I was explaining earlier that I've followed the Blue Peter guidelines of doing it. Here's something I've made before, just to make sure that it all works. And just to say, this worked before, and hopefully it works again. Okay, so let's say if I wanted to create a new container and enable the analytical store within this retail sales demo database that I have. So if I create a new container, for those of you who aren't familiar to the Cosmos DB or the Cosmos DB portal, we essentially, when we create containers via the portal, we can actually assign we can tell Cosmos DB whether we want this new container to be added to an existing container, or we can create a brand new database to do that. We can give this container a name, so analytical demo, assign it a partition key. So say if I have an ID property within my documents, which all Cosmos DB documents will have, when I'm inserting new items into this container, essentially it will fall under a logical partition of ID, and it will sit. So say if all IDs of this document were the same, it would sit underneath this petition key value. When we provision throughput, we've got two options now. So we've got this manual option, which essentially we're setting a hard limit, a hard upper limit, sorry, for our Cosmos DB containers. So as we make more and more operations against our Cosmos DB containers, they're costing more request units. Once they start to exceed this 400 value that I've got here, we'll start to have our request throttled, and we'll start to receive 49 errors. Or we've got this auto scale option. So essentially what this is, we set a max upper limit. So 4,000 is the minimum maximum that you can set, because essentially what it will do, it will our throughput will automatically scale from 10% of our max request unit limit, 4,000, so 400 here, up to 4,000. So once your requests start to exceed 4,000, then it will be throttled. But if it stays in between these two parameters, then essentially it will automatically scale your container's ability to deal with those requests. But here is where we would enable our analytical store. So essentially this will allow us to perform analytics on our data within inside our container, to perform analytical queries. So
hey, Will,
here's
I'm just wondering, sorry to interrupt, I'm just wondering if you can zoom your screen up a little bit.
I did think about that, actually. I'm glad you reminded me.
Maybe it just at my end, I just wanted to check it's visible to everyone. Thanks, mate.
Is 125 all right?
Maybe one dot more. It could be my screen.
It's that
no, it's always good to go.
ultra wide screen that you've got, Dan.
There we go. I've put it at 150, and what I'll do is I'll save some real estate here, just by putting the bar side, because all we need to worry about is the scale settings. But I want to come down here to the analytical storage time to live. So we've got two time to live settings. So this transactional time to live is we essentially would set a time with seconds, and so essentially we would configure the amount of time in seconds that our items would live in Azure Cosmos DB, and this is now for items that are stored in our transactional store. But here we've got an analytical storage time to live. So what we could do, if we're say we're writing IoT or using Cosmos DB to persist IoT telemetry readings too, we can actually set this transactional time to live lower than the analytical storage time to live. So we can save space in our transactional store, writing documents quickly to it, but then retain it for longer using this analytical storage time to live, but just by setting the amount of seconds higher, or even not setting it setting that at all, so it lives longer in our analytical store, longer than it in our transactional store. Okay, in order to actually configure Synapse or our Synapse Link, you need to enroll into the Azure Synapse Link. Now, I've done this before. From the top of my head, this was a quick just enabling it on this account. And once you've enabled it there, you should be able to use Synapse Link, but that was quite some time ago. So I think I signed up to the preview and they didn't really open the preview. So it was a real gated preview. So once it became public, it was just automatically enabled. But essentially, if you're looking to enable a Synapse Link for your Cosmos DB containers, just go into this features portal underneath settings, and you should be able to enable the Synapse Link from there. So once we've done that, I've provisioned a Synapse workspace for me to work with. Now, just before we start, essentially, in order to perform queries in Azure Synapse, we need either a SQL pool, an Apache Spark pool. And what I've done is I've provisioned an Apache Spark pool already, but I'll go through this, and what I'll do is I might just zoom out just a little bit more. Cool. Oh, just go back. So when I'm creating an Azure Apache Spark pool for my Synapse workspace, If those of you in the audience have ever worked with Azure Databricks, you'll know that when you're provisioning a cluster, you can essentially set the size of the cluster, how many nodes you want, whether you want it to auto scale, and it's almost a familiar, almost similar process in Azure Synapse. So we can just give it a name to our Spark pool. We can choose the node size, so how big we want our Apache Spark pool to be. We can enable or disable auto scale on our Apache Spark pool, and we can just get an estimation of price there. So for this one, the minimum would be $6.17, and we could scale that right up depending on how rich we are, and also how performant we want our Apache Spark pools to be. Now, when we provision a Synapse workspace, we also assign it a data lake, or an Azure data lake. And essentially what we need to do is we need to assign both the workspace and the users who are interacting with our Synapse workspace. We need to grant them storage blob data contributor roles in order for them to actually use the Spark pool and make operations inside that. And that's fairly straightforward. So what I've got, I don't want that. What I've got here is I've got my data lake storage here, and essentially we could just enable this using access control and then just add roles to ourselves in this way. It's fairly straightforward. If you're using this in production, you might have your own way that you assign roles to different users depending on what kind of contributions they need to make. But essentially the point I'm trying to make is before you can actually do anything inside Synapse Analytics, you need to grant users permissions in order to access the Apache Spark pools or the SQL pools. Yeah. Okay, so what I've got here is I've got two notebooks that I'm going to go through, but before we start that, I'm going to show you how you can actually link your Cosmos DB workspace into Azure Synapse. So here I'm in my Synapse workspace. For those of you who've ever worked with Data Factory, this may look fairly familiar, but essentially if we want to link our Cosmos DB accounts to a Synapse, we've connected to an external database now, or data source, sorry. Now, these are the supported data sources at the moment. So we've got Cosmos DB for SQL API. We've also got MongoDB API, but I believe that running analytics on your analytical store within MongoDB API Cosmos DB accounts is under gated preview. But so for this demo, we're just going to use SQL API. I've created this earlier, but essentially it's very similar to Data Factory. So we could just give it a name, and we could either connect to our Cosmos DB account via our connection strings or using Key Vault. So once it loads the key, I've got it linked before, so if it doesn't, okay, sweet. So, and we connect it to our database name, and this is how we would link. Once we've enabled Synapse Link for this Cosmos DB account, we can then add it as a link service within our Synapse workspace, which I've already done here. Oh, and this one here, that was a previous one. And also we've got we can also view files within our Azure data lake. So looking at our files here, I've essentially got 3 CSV files within my within this folder here called retail data, which I'm going to be using in this demo. Okay. So here, what we're going to be doing is we're going to be getting those 3 files, and we're actually going to write from Azure Synapse into our transactional storage. Now, so this is essentially just reading our CSV file. So while this is running, I'll make a point where from Azure Synapse, we can write our aggregations that we make in Azure Synapse to a transactional store. What you can't do is make your aggregations and your analytical queries within Azure Synapse, and then write that back to the analytical store of a container. So essentially, you read from the analytical store is a read-only resource, so you can read from your analytical store, but you can't write back to it. So if you wanted to serve that model back, serve your data back into Cosmos DB, you would write that back to the transactional store. And essentially what I've got here is I'm creating 3 Spark data frames, reading from this retail, reading these CSV files from the retail store in my data lake.
Oh, well, just quickly, can you increase your size again?
Sorry, I'm not doing so well this time, am I?
It's all good. I'm just reading the questions. Thanks, mate.
Okay. Sorry, guys. I'm like running through this and not looking. Okay, cool. And essentially with these files, these will be written to data frames. And then from our data frames, we'll write this back into our transactional store in Cosmos DB. So for those of you who are fairly familiar with the Spark PySpark APIs, this will look fairly familiar to you. So essentially, we're writing into a format for our operational our transactional data store. We're writing into that format. We're linking our service, so retail sales demo DB, which is what I called my link service earlier. We're writing it into a container. So for this one, for store demographics, we're enabling upsert, and we're just appending that data as it comes through. So hopefully, my Spark session is dying. So essentially what this is, we're just writing these 3 data frames and then persisting that into Cosmos DB. And in the interest of time, I'm actually going to show you earlier. I'll go back into my data explorer here and show you that this has been written successfully. So I've petitioned all of these containers by ID. And the reason why you would do this, for those of you thinking, okay, well, why would you petition by ID if you've got unique IDs throughout all your documents? Why would you do this? This is there's different petitioning strategies, but this is optimized for writes. So this enables us to perform really high-speed writes. And we can see our CSV, the contents of our CSV files have now been persisted as documents in Cosmos DB. So just want to see my Spark session still starting. So I'll move on to actually bringing data from our analytical store back into Azure Synapse Analytics. Oh, I ran it earlier and hopefully it won't start throttling on me. Cool. So essentially what I've got here, what I'm doing here is I'm creating a Spark SQL database. And essentially from there, I'm then creating tables to live inside that Spark database. So what I've got here is I'm creating a table if it doesn't exist using Cosmos, the operational layer. So within this options, I'm selecting the link service. So this is the link service that we defined earlier. The preferred regions. So if you've got multiple regions configured to your Cosmos DB account, you can actually select which region you prefer the table to read your operational data from, and you can choose which container you're actually going to create this new Spark table from, or where you're going to source the data. And then the magic is, so we do that for our products, our store demographics, and our retail sales containers. And then we can, from there, we've got three tables now that we can perform and display our data, perform analytics and display our data from. So in Cosmos DB, you can't perform joins across containers. But in this situation here, what I've done is I've essentially written data from my Cosmos DB containers into a Spark SQL table, and now I can perform joins and join that data together to get some insights on them. And it ends up with a created table here. So it allows us to actually perform join, or provide a way to join our data and get some and perform analytics in that fashion. Cool. And then from here, now that we've built our Spark tables and we've joined our data together, and we can write that to data frames. We can, through Azure Synapse Analytics, we could say connect it to Azure ML, perform some machine learning, build some models off that. We can connect it to Power BI to try and get some visual insights into our data. So this is just a small demo just to show you that from your operational data in Cosmos DB, you can bring it into Synapse Analytics and perform analytics easier in an easier fashion than you would traditionally in Cosmos DB. So you don't provision any throughput or any extra throughput on your Cosmos DB account. It doesn't have any effect on your transactional workloads. You can offset all this cost to Azure Synapse Analytics to get some real powerful insights into your data. Let me just get my slides back up again. Oh. Let me start from here. There we go. Am I still sharing my screen?
No, still sharing your desktop. Just reshare your slides again and we'll
Pop it up.
There we go. Cool.
That's it.
Can you see them now? Fantastic. Okay, cool. So just some things to note as I wrap up. Currently, this is generally only supported for the SQL API. Like I said earlier, the Synapse Link for MongoDB accounts and also Cassandra accounts are under gated preview. So you would you'd have to reach out to the Cosmos DB team if you're working with the MongoDB API or Cassandra APIs API accounts if you wanted to enable Synapse Link for that. And using SQL Serverless is also under gated preview as well. The analytical store, you can't, unfortunately at the moment, you can't enable it on existing containers. So this is a bit of a pain point, but it's still a preview feature. So essentially, if you want to enable the analytical store on existing containers, what you'd have to do is migrate your data from your existing container, put it in a brand new container which has analytical store enabled in order to gain benefits from that. And I'm hoping when this Synapse Link for Cosmos DB becomes generally available, this will be able to update our containers to enable the analytical store for it. You also can't disable analytical store after creating your containers. So essentially you're stuck. Yeah. There's no impact, like I said, on your transactional store in terms of request unit expenditure. So no longer do you have to crank up the RUs and hope for the best. Essentially, all the cost is offloaded to Synapse Analytics. And also, like I said, the analytical store is currently only read-only. So when we're performing any aggregations and if we want to write those aggregation results back to our Cosmos DB, we'd write them against our transactional store rather than our analytical store. And those would be served back once they're in your transactional store. They would be auto synced back to your analytical store within that 5-minute period. Cool. So that's all I've got. I hope you've learned something today, and I hope you guys enjoyed that. It was a bit of a clunky demo, but we got there in the end, I feel. So if anyone does have any questions, please, yeah, let's
really that was really awesome. Yeah. Thanks, Will. That's been fantastic. Hey, yeah, do if you've got questions, post them in the Q&A on the side. I personally have a couple of questions I'd be keen to ask if no one else has got any. Just Will, where do you? My first question is, where do you what is the problem that this is ultimately this combination of Cosmos DB and Synapse Link is solving? What's the big problem that's really addressing?
The big problem that it's, I think the big advantage of this is that you don't have to mess around with provisioning throughput to perform analytical queries. One of the biggest pain points that we found at the bank when we were first using Cosmos DB, we were trying to treat it like a normal database, and it's really optimized for transactional workloads. And with this Synapse Link, it just makes life a little bit easier. performing those analytical requirements that naturally you will need over time, because the more data you persist the more you use Cosmos and the more data you're actually collecting, you want to get some insights out of that. And this is like a really nice integrated and simplified use, a simplified way of actually gaining those insights rather than configuring your own ETL jobs. Just to try and do some simple things. So we were at the bank, just from personal experience, we were trying to use stuff using the change feed to persist it to different types of storage and components. And it's when you're using it in production environments, you're not just provisioning stuff via the portal. You've got to think of provisioning it automatically through your CI/CD pipelines. You've got to think, okay, are these certain technologies compliant? There's all these different factors that just may added to the complexity of just trying to get insights out of your data. And I think what Synapse Link does, it just really simplifies that process.
Oh, that's awesome. Do you see a challenge with a lot of people going and trying to get use their traditional relational databases and pulling analytics out of that? Does this is really not going to solve or address any of that? This is not looking to solve that problem, is it?
Sorry, you cut out a bit there.
Sorry. Do you see this as being something that could also solve problems in the relational database area in dealing with analytics, or is it typically it's only really transactional data and moving it into that that document-based or document type storage?
I think it potentially it solves the problem of actually performing analytics on your transactional workloads. There's always going to be, I think, there will always be a need for relational data stores and performing analytics that way, and there will still be a need for relational data stores. But what this does, it just provides developers and data engineers a way to perform analytics on Cosmos DB transactional data in a simplified way.
Right, gotcha. And I noticed just early on you mentioned TTL, or time to live on documents, and that's typically not something you see often in relational databases. Can you talk about that? This concept of TTL on documents, why you do that, why why that might be useful?
So one of the reasons, we investigated this when we were using it, and for time to live, we found that, as we were writing more and more documents, we were persisting documents and we didn't have a use for them. So we were just having containers where we were just writing to them. And depending on how you model your data, what you might do is you might write lots of documents to one container and then use the change feed to try and manipulate it or perform some kind of aggregation and store it in another container. And in your original write optimized container, the data would just be sitting there. And this can have an impact on performance as well. So what the time to live configuration does, it just allows us to keep data there for as long as it's needed. So maybe a week or whatever amount of time you actually need the data to sit there. And it just deletes it automatically without you having to write any of your own logic to clean up the database, so to speak.
So this might be quite useful for event ingestion or whatever, where you only need a window of data to be analyzed, and you might use a longer TTL on that analytics store. That's really cool.
Yeah,
it's pretty awesome.
Yeah.
Have you got any pointers, leads, tips, links, or anywhere where people could go and dig more into these patterns? Because I think
that is missing from my slide deck now that you mention it. What I can do is I can actually, with these slides, I can upload this to Meetup.
Yeah,
right?
That'd be awesome. Yep.
So what I'll do is sorry, go for it.
I was going to say we'll also once we've got the details, we'll put this, we'll upload this video into YouTube as well, and share the link in Meetup, and then if you've got any other material, just share that in the Meetups as well. So there's also the connected systems, and Wagner's, say hi Wagner, we'll also share in there. So we've got a couple of Meetups you can share the data into.
So Will, there's a question from Will L. Are there additional costs?
So you're charged for usage of the Spark pool and SQL pool. So those are the additional costs there. So you've provisioned throughput onto your Cosmos DB container, but now when you're performing analytics, you've also got to consider the costs for Synapse as well.
Cool. So Will, if that doesn't answer your question, then just put another question in the Q&A. And for everyone listening, we've got a poll in the Q&A about what we should do for future meetings. So if you could just jump onto the Q&A question tab.
I will say, sorry, I forgot one thing about the analytical store. While it's in preview, it is free of charge. So I think they're just opening up this preview feature for free, and then they'll publish a pricing model once they go generally available.
Okay. And just Will, another couple of questions just for everyone's information. What is Spark in a nutshell? Assume everyone here doesn't know what Spark is. Tell us what Spark is.
Spark is really it's essentially just this really optimized in-memory processor. That's how I describe it. So essentially, you can parallelize your data in memory, and it's just a real optimized way of processing data. If that's like the one-liner.
Yeah, and it's created. It's a project created by Apache or Apache Foundation, isn't it? So it's something that you can run in Azure as a managed service. Is that right?
Well, I know Databricks is like a managed platform, which essentially manages all the internal Spark configuration for you. And I think there is another service, but it's escaped me now, that provides Spark as well, apart from Synapse. I think it might be HD Insights. You can actually use Apache Spark on as well, Azure HD Insights.
Yeah, that's correct. That's part of the Hadoop set of services. That's pretty cool. So, sorry, go on, Rory.
There's another question. Just curious, how did you discover to use Synapse versus anything else?
If I understand, how do you discover to use Synapse versus anything else? I'm not really sure what that question means.
Whoever.
I guess like instead of if I interpret that as say, why would you use Synapse Analytics over something else? Say like actually using the change feed to persist to another data store. I would say that it's easier to link up and integrate together, and you don't have to develop your own ETL jobs. I hope I've answered the question as it was meant to be asked.
Well, I guess if you lead on for that, what are the competitors to this? What are the other ways you might have done this in the past that Synapse? I guess as you mentioned before, it's about you'd be doing ETL jobs, you'd be building data processing and taking stuff into a data lake and performing additional ETL on it. Is that right? Or what would you be doing in the past?
Yeah, so in the past, I've experimented using the change feed to persist it to Azure Data Lake, so just storing it as JSON files. One use case that we used at the bank is essentially just persisting the document as JSON files into archive storage just for backup purposes. You can essentially the change feed will do is you can expose the contents within the document, and then you can perform some normalization on that data yourself. So you can actually store it in relational databases, say like Azure SQL. Those are a couple of use cases at the top of my head.
Okay.
Any other questions? We've just got a comment here, a telecom company, but I'm not sure.
That replies to where Will said, are there additional costs? And then he clarified it by saying a telecom company. I'm not sure what that means.
Okay. So any other Wagner, Buddy, any questions from you guys? Oh, go on, Will.
I'm supposed to ask a question to the
Yes.
audience for.
I was just going to
cholesterol.
remind you. Yeah.
Awesome, guys.
Awesome. Okay. So my question to the audience is: once I've performed my aggregation in Azure Synapse, can I write that back to the analytical store? True or false?
And when you answer, please don't reply as anonymous, otherwise we won't know who to send the voucher to.
And while they responding, just saying hi, I was multitasking. I can say that ribs are working really good, and the Cosmos DB is looking good as well. Thanks, Will.
Hi, Wagner.
Hey guys.
Hi, Wagner.
Yeah, really good. There's a like it's exactly because it's not my area. There is a lot of stuff that I learned here.
Well, we've got an answer come through from Anonymous saying we can say
Yeah.
it is the correct answer.
that's not
Spark, a telecom company. Okay. Yes.
Yeah, that deserves a like.
Good.
There we go.
That deserves
Yeah.
a like. Just
That
for those
deserves a like.
Yeah. Yeah, we've got to publish that one. Come on. So what Will asked, what was the question again?
Once I've performed my aggregation in Synapse Analytics, can I write that directly back to the analytical store in Cosmos DB? True or false? Or yes or no?
Well, we know who Anonymous is now. Yes.
Yeah, we know who Anonymous is.
I'll just get. So is true the right answer? Just to confirm.
No.
No. Yeah.
No, you can't write it. Can't write it to the analytical store. So you write it back to the transactional store within your Cosmos DB container.
All right. Okay.
That's so we're going to need another question, maybe another question, because now everyone knows the answer to that one.
Yeah.
Okay.
As anonymous, because it just makes it really hard.
Ooh, I hope this will see if people. Okay, in Azure Cosmos DB, if I set a maximum value of 4,000 request units using autoscale, what will the minimum be? What will the minimum throughput level be?
Any answers? Yeah, we got anything coming through?
Yeah, no, we haven't got any answers yet.
Nothing yet.
Someone asked, what do you win? You win a JetBrains voucher, which gives you free ReSharper or free any JetBrains product.
Yeah, great tools for developers. Or anyone really.
There is a question here from Bruno saying, would this be added somehow to the Cosmos DB emulator or a similar approach to make dev cheap? I'm not sure. I don't think they'll add support for the Cosmos DB emulator. But with the serverless option that I was talking about earlier, essentially what will happen in terms of costs is you'll only be charged when operations are made against your Cosmos DB account, rather than now you'll have like a steady rate of throughput and you'll be charged for that at an hourly basis. The serverless option allows you to, you'll only be charged when operations are made against your Cosmos DB account. There is also a free tier option. So if you're just starting out with Cosmos DB and you're just developing proof of concepts, or you've got really, really low workloads, essentially Cosmos DB actually provides a free tier to developers where you get one database with 25 collections that's sitting inside that database, and you're not charged for it. But I think the maximum request units that you can actually provision on it is 400. So it is the bare bones minimum version of Cosmos DB, but it is free if you want a cheap data store to do some dev and test against? Just to answer that question.
Well, it looks like we have a correct answer. So Will L,
We do.
I'm just getting Will L's email address, which we won't publish, so you can just whack it onto the question. And then your voucher will be winging its way over to you, and enjoy.
He's also said I got a nice bedroom, which is yeah, thanks. I built it myself.
Did you?
No.
Oh,
Sorry, that was sarcasm. That was the English sarcasm coming out. I don't.
Yeah.
Sorry about that.
And Will also wins for being for making jokes about the name of Spark, which I missed initially. So good job.
So Will L, please just give us your email address. I don't see it here.
We got a couple of answers for the question as well, I think.
Yeah, it seems like there's a bit of a mix. You know, some people keen to do at the office. Some people keen to do live. So it sounds like there's probably a bit of both. You know, there's going to be, ideally we'll be able to stream these events and run them in person.
Because that was also one of the suggestions on the published, right? It's like an option C. Please make it in person for those that can go, but stream it and record that.
Absolutely. So that I think whatever happens, we will still have a streaming option. I think what we've got to do is figure out how to work the technology. Now that I think we have figured it out. Without Daryl, we all used to depend on Mr. Webster. So I think we just need to get the technology working at the office.
That's true.
Will L, thanks. I've got your email address, so I will organize it for you.
And I noticed that in the previous ones, we actually managed to get people outside Auckland, and they were really happy that could have the opportunity to join the meetups. So that's also going to open for other people.
Yeah, awesome. Yeah, I think that's a definite positive, definite powerful.
Yeah, I agree. It makes it bigger than Auckland.
Yeah, might have to take the word Auckland out of the Azure user group, Auckland Azure user group, right?
Oh, you could call it. We could call it the worldwide
Yeah. So
what's famous in New Zealand, Auckland Azure user group.
Yeah, exactly. We'll give away LMP, right?
Yeah.
I think we do actually in the in-person user group. I think we usually have LMP.
That's going to be the drink of choice.
Any other final questions? I've got one final thing I'd love to hear from Will on. If you're thinking about Cosmos DB, if you're completely new to it and you're going, do I want this thing? Give us one tip on what they should do when they're thinking about this. I'm obviously asking from a place of I've seen this adoption, so I'm really keen to get your take on that.
The one piece of advice that I give developers if they're new to Cosmos DB is really think about the data model that you're persisting to it. It is not your any conceptions that you have about data modeling in a relational world do not apply to Cosmos DB. It's you need to optimize your data model for requests in Cosmos DB. So that's the first bit of advice that I give to developers, and this changes depending on the API that you're using, but really think about the data model that you're going to be using within your applications and how you're actually going to structure that depending on the type of queries and transactional workloads you're wanting to perform.
Awesome. Yeah, great advice. Thanks, Will. All right. Anything? Right. Oh, maybe one final thing before we go. If you've got anything to present, you'd like to have a crack at sharing some of your knowledge. You've done some, you've seen some exciting stuff. You're doing some exciting stuff. Do get in touch. We're always keen to get more presenters come and share more content. And as we can do these things virtually now, we can possibly do it more frequently depending on the presenters we come. So yeah, please come and share.
And remember, that doesn't need to be like the bleeding edge. Like there is a lot of people on those user groups that is in all different paths of life or learning curves. So sometimes a really good use case of how I solve a problem is a fantastic thing to present, because a lot of other people might have in the same trouble. And it doesn't need to be like a full 1 hour, right? Half an hour presentation, 15 minutes presentation, talk to us. We can put like people together to fill up 1 hour, or we can do different things.
Yeah.
Just to add to that, if you've never spoken before and you're wanting to get into speaking, user groups are fantastic to do that. So even if you've never spoken before and you've got a really compelling topic, or you just want to get into public speaking, user groups are a fantastic way of doing that. And these guys have been fantastic in helping me get talks out there. So you're in safe hands. So if you're brand new to it and you're wanting to get into it, I really recommend you take the plunge.
Awesome. Thanks, Will. Yeah. Thanks,
exactly what he said.
Yeah, we're always happy to mentor people and go through your slides first and give you some feedback before you actually present.
Sweet. Well, I guess that about wraps it up. Everyone's probably looking for dinner, right?
Yeah.
All right. Well, thanks, Will. Thanks, everyone. Thanks, Wagner, and thanks all of you guys for showing up on a, what is it, Wednesday night?
Wednesday. Yep.
Level 1. Go level 1.
Thanks, everyone.
Thanks for having me, guys.
Thanks, everyone.
And see you guys next time.
Thanks, guys.
In person or not.
Mm.
See ya.